Hello everyone, welcome back to the channel. Today we will be doing this post-contest discussion for around Hello 2025. And yes, here we go. Problem A. So here basically you have to construct a matrix or a grid, you can say, of n rows and m columns such that its elements would be from 0 to n into m minus 1, and uh, so that in such a way that we have to construct that grid in such a way that we have to maximize the sum of mix. So mix is minimum excluded number. Okay, so across all rows and columns, more formally he needs to minimize, okay, maximize this thing. So if you are unfamiliar with the thing max or minimum excluded number, you can read this post subscript or the what you can say, the explanation given by them to understand what the max is. So basically, suppose yes, this is the thing we are doing. Okay, so suppose my grid is something like this, not something like this, it will be exactly like this. And yes, so suppose there are more number of rows than this 4. So if my 0 is suppose at this row and column, means at position 2 comma 3, okay, in the second row and the third column, so indexing starts from 1. So m columns and n rows. So what I can notice is that max for this row is going to be 0, right? Because it doesn't contain 0. Max for this row is also going to be 0. It is not containing 0. Max for this row will also be 0. So, and one more thing, same for the columns, right? So max for this column will be 0, this column will be 0, all these columns max will be 0, right? Okay, 0 and 0. So whatever my answer is will be contributed by this row and this column, right? So basically that is the thing. And I will arrange numbers in such a way that, okay, so suppose now, so that now I know that this row and this column are the only candidates to contribute to our answer. I will put this 0 here without loss of generality in the grid, okay, in the cell 1 comma 1. And what I will do is that I will fill the numbers, okay, sorry for the disturbance. And yes, I will fill the numbers. So if I have n is equal to 3 and m is equal to 5 as given in the sample test case, I will fill it in such a way 0, 1, 3, 4 and 0, 1, okay, not 1. What am I doing? So 5 and 6 maybe. Yes, and one more thing to notice is that whenever you put this 1 in the row or the column, so if you put it in the row, the mix of column is going to be 1. Okay, so that is basically the fixed thing, and mix of this row is going to be 5, right? So our ultimate answer is going to be 5 plus 1. So what if I put these numbers 1 2 in this order? So 0 1 2 3 4 5 6. So my mix of this column is going to be 3 and mix of this row is going to be 1. So our answer in this case would be 3 plus 1, which is less than the thing that we can get maximum, right? So I will put this 0 1 2 3 up to m minus 1. okay, not m minus 1. So basically if the size of the row is larger, you will keep putting elements consecutively starting from 0 in that row. Okay, if a row is larger, you will keep putting elements in the row. If the column is larger, you will keep putting elements there. And see, here the row is larger, right? M is equal to 5. So max of that row is going to be the m itself, and this column max will be 1. So can I say that my answer is going to be maximum of n comma m plus 1? Yes, I can definitely say that, right? So code is pretty straightforward, nothing really tricky in the code. Yes, fairly simple code. Yes, taking the input and outputting maximum of n comma m plus 1, and it nicely got accepted as well. It passed pre-tests and now it is accepted. So yes, system testing is going on. Let's head to the problem number 2, that is B. So wait, so view the changes. So the change was that, so they gave this thing a instead of b, and that was basically the mistake. And the operations you do are, I think, persistent. So that was basically the thing. And let us take a look at the question. So you will be given some array a. So let us take this test case. Okay, let's take this one. Paste. So basically here n is equal to 5, n is equal to 5, k is equal to 3. So basically you can alter any 3 elements from this array, right? That's basically the thing. And for n is equal to 5, what I can notice is that, so my first intuition is that, so listen, my first intuition to solve this problem is going to be, suppose uh, one more test case. Where is it? Let us take this one. So basically n is 11 here and our k is equal to 4 here. Okay, so if I sort these elements, they are like 1 1 2 2 3 3 3 3 and 4 4, right? So my first intuition is that the element that I'm going to erase, okay, one more thing is that I want to erase all the elements in one go. Okay, I want to erase all the elements in one go. What I mean by one go is that, so suppose you try to erase, so erasing step is only going to be the one time. Okay, only once. Okay, only once. Okay, not only once, sorry. So what I am saying is that for every number, so if this is 3, okay, it is 3. So for, if you want to remove this 3 from the array, you'll select this segment, right? Okay, not exactly this. So you want to remove all these elements. So you will start selecting from first to the last index, right? So because first index contains 3 and and the last index contains 3 as well. So if I uh, directly choose my L as 1 and R as 11, the minimum in this range is going to be 1, right? Isn't it? So that is basically the problem. What I can see is that that is basically the problem, right? If I want to erase 3 but 1 comes in my way, right? So to erase 1, okay, to erase 1, if I select L is equal to 3, so which is basically the index of 1, the first one, and the last one, the index of the last one is 3 and 3 and 3, 9. Okay, so if you select these, then you notice that it is easier to remove. Okay, removing one is a must, right? So you will remove one from here and here if you try to take L as 3 and R as 9. So okay, so basically I want to remove this one first and then other elements. So okay, that may not be the point here. Okay, one thing I can notice here is that if I completely want to remove every element from the array, so what I will try to do is that, so I notice that 3 is appearing maximum times, right? So again, that, so basically if I sort the elements in, what you can say, if I sort the elements in the order of the frequency in which they appear, so I have did exactly that here. So 1 1, so its frequency is 2. Okay, wait, so its frequency is 2, its frequency is also 2. Okay, this has to be on the right side of the 4. So again I'll draw this 1 comma 1 comma 2 comma 2 comma 4 comma 4 comma 4 and 3 comma 3 comma 3 comma 3. So what I can notice is that, so my k is equal to 4 in this case, right? My k is equal to 4 in this case. So I will try to do the thing which is, so one thing is for sure. So if you want to remove everything from the input array, this is the key observation. So if you want to remove everything from the input array, you need to do the operations which are equal to, which is equal to number of distinct elements in that array. Okay, so here if k was 0, if k was 0, so your answer would have been 4. Okay, because there are 4 distinct elements in the array. If your k was 1, your answer would have been, so you can basically change this element to some other element. Let's suppose 2 or 4, you can say, or some elements from these things. So if k is equal to 1, you can change this one but not its colleague, this one. So again your answer would have been 4. What about k is equal to 2? So again you would have changed these two ones to twos, so it would have become 2 2, and every other thing is similar, right? So you can club these twos in one go, right? And in only one operation you can remove them. So here your answer would have been 3. So again for k is equal to 3 as well, you can remove this 2 and make it 3 or 4, something like that. Not something like that, basically the elements which occur on the right side of that, this 2 in the frequency based sorting. And for k is equal to 3 also my answer would have been 3, right? Okay, and what about k is equal to 4? So this is basically the sample test case given, so k is equal to 4. So I can convert all all this 1 comma 1 comma 2 comma 2 to 4. So it will be basically 4 comma 4 comma 4 comma 4 comma. So how many operations do I need now? So one for this thing and one for this thing. So my answer should be 2 in this case. So is it? So yes, it is basically the 2. And here also you can see that k is equal to 0 and number of distinct elements after all the k operations is 1 2 3 4 5. So basically my answer is 5. Here you can change everything to one number, and here also you can change 3 to 2. Here, okay, let's take a look at this test case. We copied this, right? We copy pasted that. So here, frequency based sorting would give us 1 2 3 4 5. I will change this 1 to 5, then it will become this thing. I will change this 2 and 3 also to the 5. So basically my array would be something like this, and in this case my answer will be 2, right? Because there are two distinct elements in the array. So is it? So yes, answer is 2. So that is basically the logic. Sorry for what you can say. Sorry for some unclear sentences that I said or statements that I made while saying the solution initially. But in the second part, basically this thing is the logic. So you sort by frequency and check how many different numbers that you can neutralize to the one number in the array which appears to the right of them in the frequency sorting. So let us directly head towards the code. And yes, taking the input using one based indexing and storing the frequencies. I don't know why I sorted this v vector. There is no need to sort that v vector, and answer is equal to m dot size. So basically you initialize answer with the size of that map. Okay, the basically the number of different integers that appear in the array, and you make one vector store. So you use some auxiliary space, you keep pushing back the frequencies, and you just sort them, sorting the frequencies. And this is basically the heart of the solution. You keep on iterating over the elements of the store, and you keep on checking that you can utilize that element's frequency with available k or not. And if answer goes less than or equal to 0, so that it can happen that answer will go less than or equal to 0. I will show you why will it happen. So suppose my n is equal to 3. So my n is equal to 3 and k is suppose 5, right? And my elements are just 1 1 1. So frequency based sorting would give me 1 comma 1 comma 1, and the elements, the only element in the store vector would be 1. Okay, 3. Okay, and I will initialize answer with m dot size, which will be equal to 1 because there is only one different element here, and store will be 3. And basically, will it go negative or will it stop at 0? Okay, you can check that for different inputs. So here my answer will be 0, so which is not possible. So if answer is less than or equal to 0, if it goes down than that, basically you will set it to 1 and finally outputting the answer. So is it accepted? Yes. So this is basically the solution for problem B. So let's head to the problem C. So problem C is very nice problem. So basically you will be given two numbers. So I think I devised a really good solution for problem C. Problem C. Something related to XOR. Okay, so you will be given two numbers L comma R. So you have the numbers L comma L plus 1 comma L plus 2 so on up to R minus 2 R minus 2 given that it fits in the range L comma R, both including R minus 1 comma R. So basically you have these numbers at your disposal and you can choose any three distinct numbers, right? So A comma B comma C such that A XOR B plus B XOR C plus C XOR A is maximized. So this is basically the question. Okay, so what I can notice is that, so if I check bitwise, okay, independently bit by bit, suppose some ith bit. So there are 8 different combinations, right? 0 0 1 0 0, okay, 0 0 0 0 0 1 0 1 0 0 1 1, oh, 1 0 0 1 0 1 1 1 0 and 1 1 1. And if I consider bitwise, so okay, so answer for this will be A XOR B plus B XOR C plus C XOR A will be 0. Okay, for this it will be 2, for this as well it will be 2, for this also it will be 2, for this also it will be 2 2 2 and 0, not 2. Okay, so what I can notice is that if all the bits in that position of A, B, C are 0, then they are not contributing anything to my answer, right? So this is basically the thing. So I will try to match this combination to uh, boost my answer, right? So I will explain you by these sample test cases. So suppose you have 6 to 14. I don't know if they have given this test case, but let's consider it. So it is 0 1 1 0 0 1 1 1 1 0 0 0 1 0 0 1 1 0 1 0 1 0 1 1 1 1 0 0. So basically that's the 12, 1 1 0 1 and 1 1 1 0. This is 14 and this is 7, right? Okay, so what I can notice is that, so if there exists a power of 2 in this interval, is there any? Yes, there is. There it is, 8. And if I do this thing, if I consider 8 7, okay, if I consider 8 7, so one thing you know that you are not going to make a stupid choice to choose the three numbers which are greater than or equal to 8, right? So that will basically vanish your the most significant bit, right? So we have seen that here in the effect, right? So basically that's the thing. What you need to do is that select one power of 2. Okay, select one power of 2 and one number less than that. Okay, so one number less than that, and one number less than that as well. So if it fits in the constraints, so 110, or if it doesn't fits in constraints, you are going to take one number bigger than that, so it will be 1001. So basically you can observe that XOR of these two numbers and these two numbers when added together gives you the maximum result possible. So it will give you some maximum result. Okay, so this guy will provide, okay, you can do that, you can verify that they indeed give the maximum result possible because of this thing, right? So 10 is the maximum thing that they can contribute, right? So not more than that. And all these combinations can give you that contribution, right? So basically that's the thing, that's the maximum that you can achieve, right? For per bit of those three numbers. So I can notice that there is no any 0 0 0 combination or 1 1 1 combination in the ith bit of any of a comma b comma c. So now I'm good. Okay, good to go. And here as well, so suppose it was 8 to 14. Okay, so okay, wait, this is the only thing, this only is the thing. So you cannot take this, right? So 6 doesn't fit in your constraints, but basically you can take this, right? So again, basically if you try to calculate the value mentioned in the question, so basically these two values are same, because again there is no combination of 0 0 0 and 1 1 1 here as well. That's basically the thing. And this is the thing for what you can say, the number, if the power of 2 is present in between those numbers, right? So power of 2 and power of 2 minus 1 also needs to be present there, right? So if it is 8 to 14, you cannot cook up with 8 7 and 9, you can say, because 7 is not in the range, right? So what will you do in this case? So yes, let's check. So let's take a look at this thing. Okay, I found it. I found the test case. Okay, so consider 16, L as 16, and our R as, okay, 25. Okay, so wait till, not wait, I'll pause the video and I'll pause the screen recording and note down the values of binary values of this 16 to 25. Okay, okay, so this is the value for 16 and this is the value for 25. So what I can notice here is that there is no power of, okay, let's start from 17, it would be nice. Okay, so I can notice that there is no power of 16. Okay, no power of 2, no power of 2 in the play. So what I can notice is that my first bit, okay, so this thing, my first bit is not going to contribute in my answer, right? So everything I need to do is based on the thing that I have to consider the bits which are not consisting of bit 1, because it won't make any difference, right? Because if you choose any a comma b comma c from 17 to 25, the combination, the most significant bit, combination of most significant bit would be 110, which will contribute 0 to our answer, right? So that is not good. That is not good. That is bad. Okay, so what I will try to do is that, so basically answer for 17 to 25 will be same as the answer for 1 to 9. Answer for 17 to 25 would be same as answer from 1 to 9. Nice, right? So basically this is really interesting thing, right? So what you will try to do is that you will try to find the power of 2, the maximum power of 2, such that it has multiple in this range. Okay, multiple in this range. Okay, battery saver is on. Yes. So, okay, sorry for the disturbance. And so the answer for 17 to 25 would be same as answer from 1 to 9. Right. So I will try to find the biggest power of 2 which has multiple from 17 to 25. Right. So here my answer would be like, I will consider this number. I will consider this number and this number. Okay. So my answer would be 23, 24 and 25. Also 22 comma 23 comma 24 is also can be the answer, right? So we have seen this. So that is basically the thing. I will uh, try for every power of 2 which is less than or equal to 25, right? So you don't want to check for 32, because there is no way you are having multiple of 32 in the lesser number than 32, right? So you will check for 16 and then 8 and then 4, then 3. Okay, not 3. Why 3? Man, I'm crazy. So 1. So for checking for 16, I noticed that I am not getting any number. So power of 2 and one number less than that. So I want to have 15 and 16 as well, right? So suppose 8. So here I have multiple of 8 which is 24, right? And also 24 minus 1, 23 is also available. So I will stick with this thing. I will stick with 8 and I will calculate the answer, and my answer will be simply left plus, okay, left plus p is power of 2, p minus l percentage p. This will be my power of 2. Okay, not power of 2, not power of 2, this will be my multiple of p. Okay, basically you can play around with this formula. It is easy to derive, and that's not the big deal. And yes, basically this number, let this be a, and you have to output a comma a minus 1 comma, so a minus 2 or a plus 1. Okay, so if this is in range you can go with this, and if that is out of the range you go with this. So this is basically the solution. Yes, so let us directly head to the code. Yes, I am calculating the power of 2 which is less than or equal to r, and iterating over all the powers of 2 which are less than or equal to p2, and this is basically the remainder. I don't know why I did that in the contest. Okay, I didn't use that. And if this thing, if this number is less than or equal to r. Okay, this is the multiple of that thing, what you can say. Mm, this is the multiple of power p. So directly outputting a and a minus 1 and checking if a minus 2 is greater than or equal to l. If it is, output that. If it is not, output a plus 2. Okay, not a plus 2, a plus 1. And yes, that is basically the solution. And yes, hope it helps. And this is the first video I am doing on the post contest discussions. Hope you enjoyed it. And yes, thank you for watching. It means a lot to me. Yeah, consider liking the video and staying subscribed, staying tuned to the channel. Yes, see you again. Hopefully, hopefully, or surely. Yes. Or did that got accepted? Yes, smoothly. Yes, see you again.